Hi everyone. I am Sachin Vivare. Yes, we are going to start here a new topic known as this one is a partial differential equation. Okay. Partial differential equation in short we'll say PDE. It have again the same weightage of 17 marks. One of the simple topic, easily you can score that 17 marks. So a few of the things that we are going to see here right now. The first thing throughout the topic, the partial derivatives, which are of the first and second order, we are going to denote by this notation. So every time this P denotes dou z by dou x. For Q we say dou z by dou y. Then R is a dou 2z by dou x square. S is a dou 2z by dou x dou y. T is a dou 2z by dou y square. So first order partial derivatives we are going to denote by the symbol. These all are small alphabets PQ, and second order partial derivatives we denote by R, S, and T respectively. Okay, so that about the notations that can appear in the numericals there. Okay, so already you know the differential equation is the equation in which the differential coefficients are present. Here we have the first article is known as a formation. Okay, this one is a first article that we have. I will say this one is a formation of partial differential equation. Okay, formation. So how to form the differential equation? So we already seen in LDE, when we solve the differential equation in solution we get arbitrary constant. Okay, when we solve a second order differential equation, there will be two constants C1 and C2 that in the solution. Okay. So in reverse way, when we eliminate that arbitrary constant, we get a differential equation. Now, when function depends only on one variable, say y is function of x, then the differential equation is ordinary differential equation. But in this case, we are going to say z is a function of x and y. So z is a function of x and y, or we are going to say here as z is a function of more than one variable, so the partial differential coefficients appeared and corresponding differential equation is known as a partial differential equation. So the one of the most important thing that you should remember, and that is when you eliminate, by eliminating two arbitrary constant, we or one arbitrary function. For example, if you have z is equal to ax plus by, okay, and we are going to eliminate this a and b, then we are going to get first order partial differential equation. Or if we have like function of xy is equal to 2, so this is only one arbitrary function phi is there. Okay, so when we eliminate these two arbitrary constant or one arbitrary function, we get first order partial differential equation. Okay, and there's another thing, when we eliminate two arbitrary function, if by chance there are two arbitrary function present in the equation, then we get second order differential equation. So that about a formation of differential equation. By eliminating constant or arbitrary function, we get a differential equation. Some of you may think, what is this arbitrary? Okay, so when we have the fixed constant like z is equal to 2x, okay, then this 2 is a fixed constant. But when I say z is equal to cx, and this c is an arbitrary constant, if it is taking any value, then it is known as arbitrary constant. Similarly, when we have in general the function given like f of x, and we are not given that what is that fx, so f is arbitrary function. It can be any function. It can be log x, tan x, e raised to x. So that about arbitrary function. So when the notation comes f1x, phi1x, or phi of x, psi of x, anything, so that are considered as an arbitrary function. So remember one thing, that formation of differential equation from last 3 years, that was not asked in the exam, but understanding is very important, because that will benefit you to understand the further articles, like solving the differential equation. Then you don't have any doubt why the solution contains two arbitrary constant or one arbitrary function or two arbitrary functions. So you will not have that doubt. So formation of differential equation, we are going to see these 4 examples in the next video. So you will observe First example contain a and b are arbitrary constant, whereas r is a fixed constant because it is given r is a radius of that sphere. In example 2, again there are two arbitrary constant. So first two example contain two arbitrary constant. It represents first order partial differential equation. Third example contain one arbitrary function f. So it again represent a first order differential equation. But fourth example contains two arbitrary function f and g. So it will gives you a second order partial differential equation. Okay, so that about the theory. We'll see the formation of PDE in the next videos. Okay, so thank you. So let me start here. The first example of formation of a PDE. We are going to form the partial differential equation. So question can come in the two ways. This is the first way, that is in the word problem. You can observe in the word problem it is written, form the differential equation by eliminating arbitrary constant of a family of spheres with a center on xy plane and the radius, that radius is a fixed radius of that sphere, and that is r. So as center is in xy plane, the center is in xy plane and radius is r. So that is the given equation. So from this equation, for this equation, we can say we have to form the partial differential equation. So the method is very simple. First, you have to observe how many constants are there that we have in the differential equation. Here, a is one of the constant, b is another constant. These are arbitrary constant. R is a fixed constant. So don't worry about R. As two constant are there, just differentiate this equation with respect to x and with respect to y. We'll get two more equation, and from these three equation we are trying to eliminate that a and b. So equation should be free from a and b, and it will be in terms of dou z by dou x and dou z by dou y. So let me differentiate this equation one with respect to x. So derivative of x minus a bracket square is a 2 times x minus a. Derivative of y minus b bracket square with respect to x is a 0. Derivative of z square. Now remember, z is not a constant. Z is a function of x and y. So derivative of z square is a 2z into derivative of z, with that is dou z by dou x. And derivative of r square, that is a fixed constant, that's a 0. Okay. So simplified, we get x minus a is equal to minus zp. Similarly, when we differentiate it with respect to y, we get y minus b is equal to minus zq. Now just observe this equation 1, this first equation, this is a given equation, then equation 2 and equation 3, and you will find the equation which is free from constant is like this: z square in bracket p square plus q square plus 1 is equal to r square. And that about the final answer. That is a partial differential equation where the p and q are dou z by dou x and dou z by dou y respectively. Okay. Similarly, you can go through the second example and you'll get the questions are really simple in the formation, because as there are two arbitrary constant, differentiate with respect to x, differentiate with respect to y, and try to eliminate this a and b, and you will get the relation which is free from the constant, and that about the answer. Okay, thank you. Okay. Now the next two examples for formation of a PDE. In the first two examples, we observed how we eliminate the constants and we get the partial differential equation. Now these are the last two examples where we are going to eliminate arbitrary function. So if you observe, the given equation is here, z equal to f of function of x square minus y square, and the question is eliminate that arbitrary function f and form the partial differential equation. So as one arbitrary function is there, so you have to differentiate only with x and y once there. That means you have to calculate first order PDE. So differentiating with respect to x, dou z by dou x as it is, derivative of f of x square minus y square is f dash of x square minus y square into the derivative of a bracket, that is a 2x. Okay, this is partially with x. So similarly, differentiating partially with y, this is a dou z by dou y, derivative is f dash into the derivative bracket with respect to y is a minus dou y. So that about the two equations. So now just observe 1, 2, 3, and you should think by which way we can eliminate the arbitrary function f. And here the way is not only substitution, it is just division. You can say equation 2 is divided by 3, f dash gets cancelled, p upon q will be is equal to minus x upon y, and you get py plus qx equal to 0. Py plus qx equal to 0 is the answer, which is free from the arbitrary function f, and that is a partial differential equation. Okay, so come to the last example now, z. So here the difference is now z is a function of two arbitrary function f and g. So in this case we have, as two arbitrary function is there, so it is a second order PDE. So we have to calculate first all first and second order partial derivatives. So first of all, differentiating with respect to x, derivative of x into fy remains only fy. Derivative of y into gx becomes y into g dash x. So that is a dou z by dou x. Similarly, you will find dou z by dou y, you will find dou 2z by dou x square, dou 2z by dou x dou y, dou 2z by dou y square. Now, when you calculate this dou 2z by dou x dou y, yes, you can differentiate equation 2 with respect to this equation 2 with respect to y, or this equation 3 with respect to x. You will get the same answer, because when the functions are continuous, in general, these partial derivatives commutes. Okay, so means they are same. So don't worry about it. So once you get first and second order partial derivatives, now you have to observe the equation 1 to 6. Okay, 1 to 6, and you have to think by which way you are able to eliminate the function that f and g. So in this case, I observed first of all that from this, if we multiply equation 2 by x and equation 3 by y, we get xp plus yq in like this. And then if we simplify, we have the values for this bracket, this is the original function z, and this bracket f dash plus, and that is the value s. S is nothing but dou 2z by dou x dou y, and we get the equation which is free from f and g, that is free from the two arbitrary function fg, and that's the corresponding PDE. Remember, last 3 years none of the question was asked on this formation of a PDE, but I already told you it is important in the sense, you will come to know later on, when we solve the differential equation in solution, you may have either arbitrary constants or you may have arbitrary function. Okay, so that's for today. Thank you. Hello, welcome in the second session of a partial differential equation. So today we are going to see a topic which have the weightage of a 2 marks, weightage of a 2 marks in the final exam. Uh, the topic is very simple. We can get a solution just by direct integration. So every time, just you have to integrate one by one, so that you will get the solution of partial differential equation. So these are the 4 examples that we are going to complete in the today's session. No any formula required, just the integration that you learnt in the 12th standard that you require here. So let me see the equations solvable by direct integration. Okay, so let me start the first example. First example of equation solvable by direct integration. Right now, the question we have this is the first question that we have in our course notes. So dou cube z by dou x square dou y plus 18xy square plus sine of 2x minus y equal to 0. Now our aim is to remove this differential coefficient, and we are going to find z as a function of xy. So that is our final answer. So just we have to remove this differential coefficient one by one. So we'll go from left to the right. So first we have to remove this dou by dou x. So its anti-process is the integration. So let me integrate this expression with respect to x 2 times, then integrate with respect to y, and we get the answer. So the let I say, uh, integrating this equation 1 with respect to x. So we get here dou 2z uh, by dou x dou y, because the integration with respect to x and dou by dou x are the anti-process, gets cancelled. So only second order derivative left, plus 18 integration of x is x square by 2, y square as it is, because we are integrating with x partially, so that time y is a constant. Integration of sine is a minus cos 2x minus y upon 2, okay, is equal to. Now here we can write the constant of integration, but remember in the partial when we integrate with respect to x partially, that time function of y is the constant of integration. So I will say f1 of y. This is f1 of y is my constant of integration. You can use any symbol. You can say phi1 of y or psi1 of y, anything. So this is the constant of integration. Okay. Now again integrating with respect to x. So if we integrate this again with respect to x, now we left with dou z by dou y only. Okay, because we are integrated this with respect to x, plus this is a 9 here, so this is a 9 x cube by 3 y square as it is. Integration of this minus cos is a minus sine 2x minus y upon 4 is equal to, now integration of f1y is x f1y, because f1y is a constant and integrating with respect to x, plus you have to say constant of integration for the second integration is a f2y. As we integrated with respect to x, constant of integration will be the function of y. So that is the new concept for you. Okay, and at last integrating with respect to y, so that becomes only z now, integrated with respect to y. So z, this is a 3 gets cancelled, this is 3 x cube y cube by 3. Okay, integration of minus sign will be that minus minus plus cos of 2x minus y upon 4. It become minus 4 because upon that minus 1. So this is y, minus y is there, the y, and that about 4 is equal to, now RHS we are integrating with respect to y, remember. So this x integration of that f1y, small f1y. So this f1y is a constant previously, because we are, means it is constant when we integrate with respect to x. But now this is the function of y and we are integrating with respect to y. So let me assume that integration of small f1y is a capital f1y. Okay, some function. Okay, because that is the general function, we don't know. So integration of some function will come another function. Similarly, the integration of that f2y with respect to y will come capital F2y. Okay, we are assuming this, plus the constant of integration, because we are integrated with respect to y, so small f3x. So you can say where capital F1 and capital F2 are integration of small f1 and small f2. That also you can write. This is your final answer. So questions are very simple. That is coming for the 2 marks. This is 2 mark question. Okay, 2 mark question where you can mention capital F1 and capital, or if you not mention, that is also okay. Okay, so that's about the final answer. Thank you. Okay, so we'll start here the second example of a partial differential equation. In the second example, uh, there are two more examples that you have. Total 4 examples that we have in the handout. Out of that, second and third, it is for the practice yourself. Solve it, submit it on the WhatsApp. I will cross check and I will tell you whether you are correct or not. Otherwise, we'll see in the Zoom session. Okay, so right now this is the fourth example I'm taking because it's different. So the question is a solve dou 2z by dou x square plus z is equal to 0, and you are given at x equal to 0. At x equal to 0, the value of z is e raised to y, and at dou z by dou x value is 1 at x equal to 0. So this is the given thing, and the question is solve dou 2z by dou x square plus z equal to 0. Remember, the previous 3 examples are little different, where dou 2z by dou x square, or the differential coefficient, is a given as a function of x and y, as a function of x and y. Here, this differential coefficient dou 2z by dou x square is not given as a function of x and y. It is again given in terms of z. So in such a case, this equation can be solved just like our LDE, linear differential equation. Let me assume that capital D is the differential coefficient dou by dou x, dou by dou x. So it represents d square z plus z. This equation become d square z plus z is equal to 0. So z is taken common, d square plus 1 of z is 0. So this is the auxiliary equation. We get the roots, and we know in LDE, this is for LDE. Don't write this in the exam. This in LDE we write the CF, that is our solution, is a C1 cos x plus C2 sin x. In this case, as we are saying, this is the we are solving the partial equation. So the constant is not C1 and C2, they are function of other variable. If you observe, this is the differential equation in terms of x. So the constant will be the function of other variable, that is function of y. So z is equal to C1 is replaced by function of y and C2 is replaced by function of y again. So f1y cos x plus f2y sin x. So this is the general solution. This is the general solution of the given differential equation, but we are given some we can say initial conditions. Using that initial condition we get this particular solution, and for getting that particular solution we observed the first condition. If we use at x equal to 0, the value of z is e raised to y, so we replace the value of z as a e raised to y and we replace x by 0 in RHS. We got function of f1 of y is e raised to y. So we got f1 of y, so we replaced in the z here. So that is the but one more arbitrary function is there, and that we can find out by the second condition. The second condition we are given dou z by dou x is equal to 1 at x equal to 0. So the value of dou z by dou x at x equal to 0 is 1. So first we calculated dou z by dou x from this expression. This is the value of dou z by dou x minus partial differentiation with respect to x, treating y as a constant. Replace x by 0 and we get f2 of y as a 1. So at the end we get this particular solution. So this is the use of that initial conditions. By the initial condition we get that particular solution. So this is only the example which is a different. Otherwise all the three examples you can solve it by direct integration. But remember one important thing: when you integrate partially with respect to x, treat y as a constant and take constant of integration as a function of y. Okay. Similarly, when you integrate with respect to y, treat x like constant and take constant of integration as a function of x. So that about the solving by direct integration, and these examples have the weightage of the 2 marks in the final exam. Okay.